All right, Bulldogs, this is the Unit 1 review matter test review. And so, just by going through and you can see the answers to the first page. Please be careful with your elements and compounds, of course. Hopefully you'll do a little bit of studying tonight. So let's go to the second page. You can always stop this and look at the answers. There's a second page. This test is very, very similar to this review. And let me go to the third page, which is the math portion. So this is the one you got to be careful with. So I'm going to go ahead and go through the remaining part of this. I'm not going to worry about this math problem here. You shouldn't have one of those on your test anyway. But I will go through this math problem again. Let's look at the significant figures. So you got number 9. If you look at the number 101, there is a 0 in between two ones. That makes 3 sig figs. So we talked about the 1.000. The zeros are significant because of the decimal, so there's 4 sig figs. In the number 632,498, there are 6 sig figs. And in this number here, there are only 3. These zeros are called leading zeros. They do not count. So the only ones that do count are the 4, the 7, and the 1. We talked about scientific notation, where the only numbers you look at are the ones before the multiplication symbol, which they're right here, 6.02. The 0 is significant because it lies between a 6 and a 2. Those are 2 non-zero digits, so we have a total of 3 sig figs. Going back down to the other scientific notation number, we have 2 sig figs. That 0 is significant because of decimal. And here we have 0.35002. There are a total of 5 sig figs. The zeros in the middle do count. The 0 in front, leading 0, does not count. So be careful about that. Now the rules are going to be on your reference sheet, which is stapled to the back of your test. All right, so now we get into rounding with significant figures with addition and subtraction. So I'm going to look at this one right here, 120.34 plus 47.2. Now the rule is, with addition and subtraction, you look to the number in the problem that has the fewest numbers past the decimal. And that would be 47.2. It has one number past the decimal. But also, if you line that up right, you can take a line and divide it where you see what they do share and what they don't. What they do share, those two numbers, is the 3, and they also have the 2 in the tens place. So the 4 is out. They don't share that. So, excuse me. So you really, all you have to do is add the remaining numbers, and you are set. And there's your answer, 167.5. If you look at this one here, we have 56.476 plus 0.0048. And so now, same kind of thing happens. We divide it, and the 8 is out, okay? So we all have numbers in the tens and thousands spot. So now we got to round accordingly. 6 plus 4 is 10. That makes 8. 4, 56,480. You box your answer like that. Okay? When you multiply and divide, you aren't looking for the number of the number of decimal places past the decimal or to the right of the decimal. You look for the fewest sig figs possible. That will determine how many sig figs will be in your answer. With this one here, 8.2 is 2 sig figs, 22.02 is 4 sig figs, so my answer must have 2 sig figs. And when I multiply it out, this is what I'm getting. But if I'm careful, I can round to 180 without a decimal, because with a decimal that makes 3 sig figs, but without the decimal that makes 2. So 674 divided by 22.3. I'm sorry, 22.23. Let me get that straight. 22.23. Okay? And so now, when I do that, I'll get my calculator ready to go here. 674 divided by 22.23. My answer turns out to be 30.319 and some other numbers. But I only need 3 sig figs in my answer. And so I'm going to look at these 3 sig figs right here. My number comes out to be 30.3. The other one is 712.8 divided by 21. 712.8 divided by 21. We get 33.94. And that's as far as I really need to go because my number in the word in the problem has fewer sig figs, 21, that's 2. So my answer must have 2. So now we have to round this number up. So this actually rounds to 34, and that'll be your answer for that one. 2 sig figs is the answer. Putting numbers in scientific notation is not hard. Let me make it a little bit bigger so we can all see. All right, 422. Your old decimal's here. In scientific notation, you want your decimal to be between the first 2 non-zero digits. And now you just count back to the old decimal. 1, 2 spaces. Now that's going to be your exponent too. So you're going to write 4.22 times 10. This is the way you write it. And since it was 2 spaces this way, we're going to put a 2 as the exponent. It's a number greater than 1. That means your exponent is going to be a positive. We have 104 million. The decimal in that number is here. We want the decimal right there. So now we're going to count back to our old decimal. 1, 2, 3, 4, 5, 6, 7, 8. Okay? And that means we have 1.04 times 10 to the 8. It's a number greater than 1. Exponent will be positive. Okay. We have 8,243. Old decimal is here. We want our new decimal for scientific notation to be there. And so now we're going to count backwards. 1, 2, 3. 8.243 times 10 to the third. Okay, positive exponent. So for your next number, 0.00382, there's my old decimal. My new decimal is supposed to go right there. And so now, right there, and so now I'm going to count to the left. And when I go to the left, that means my exponent is going to be negative. So 1, 2, 3. So it's going to be a minus 3. And it's going to be 3.82 times 10 to the minus 3. And the last one for here. And then I'm going to do something like getting a number out of scientific notation. Okay, old decimals here. We want our new decimal to be between the first 2 non-zero digits. Let's count backwards to the old decimal. 1, 2, 3, 4, 5 spaces. My scientific notation number is 9.12 times 10 to the minus 5. It's a number less than 1. But what if I have a number in scientific notation and I want to get it out of scientific notation and make it a standard notation number? So let's go 1.35 times 10 to the third. Let's change that to a standard notation. This exponent means we're going to move the decimal to the right 3 spots. So here we go. I have 1.35. Move my decimal 3 spots to the right. 1, 2, 3. Fill in my space with a 0. My number is 1,350. I can do the same with a number that is less than 1. And we'll use 0.00025. Oops, let's change that. We want a number in scientific notation. So 2.5 times 10 to the minus 4. All right, easy. That negative number means my decimal is going to go to the left. And so now I'm going to hit my 2.5 and put it right here. I'm going to move my decimal 4 spots to the left. 1, 2, 3, 4. Put my new decimal down. Fill in the blanks with zeros. And so my new number turns out to be 0.00025. Okay? Easy enough. Now, last stuff we're going to talk about is the density calculation stuff. Where is it? There it is. So density equals mass divided by volume. You can use this density triangle if you draw it on your test tomorrow. So for the first one, we have a 40-gram mass, and our volume is 5 milliliters. 40 divided by 5 is 8. That means 8 grams per milliliter. Those are the units for anything in density. We have a density of 48 grams per milliliter and a mass of 96.4 grams. We need to find the volume. Volume is going to equal mass divided by density by looking at our density triangle. So mass divided by density, volume equals mass divided by density. Our mass is 96.4 grams. Our density is 48 grams per milliliter. And when I divide them out, I'm just going to round a little bit, not even sig figs, 2.0 milliliters. I'm just going to round it to that number. So 2.0 milliliters will be my answer. And then the last one, volume again. Volume equals mass divided by density. The mass is 1,024 grams. The density is 256 grams per milliliter. When I divide that out, 1,024 divided by 256, I get 4. So 4 milliliters is going to be my volume. Okay. Hope this review has helped. Study your terms, what properties are intensive, extensive, types of extensive properties, types of intensive properties, physical, chemical changes, those kinds of things. Your sig fig rules will be there with you tomorrow. And all I can say to you is good luck.